So now we're going to look at being able to more efficiently find the number of combinations and the number of permutations. And I'm going to show you how to do this by utilizing a formula, and then I'm going to show you as well how to use the calculator to compute the formula for yourself. So we have these two formulas that look almost the same. The number of permutations is going to be equal to the formula n factorial. So whenever you see an exclamation point in mathematics, that's called a factorial. So it's equal to n factorial divided by n minus r. Right? So r is the number of elements that you're picking, and n is the total number of elements. Okay, so n is total, and r is the selected. Right? So remember, before in the example, we selected 2 elements out of 4, and then we selected 3 elements out of 4. So n would be 4, and then r would be 2 or 3, depending on which of the problems we're looking at. The number of combinations is almost the same formula, except that now we have an r factorial in the denominator, as well as the n minus r factorial. All right? And I guess the question some of you might be asking is, well, what is a factorial? Well, factorial contains the word factor within it. And essentially what you do is you just multiply all the numbers from the given number down to 1 in succession. So for instance, if I said 3 factorial, that's equal to 3 times 2 times 1, which is 6. If I said 5 factorial, that would be 5 times 4 times 3 times 2 times 1, which is 120. Right? So a factorial is just a way of saying I'm going to write all the numbers from the number down to 1 in succession. By the way, just as 1 factorial is equal to 1 and 0 factorial is equal to 1. All right, so now this is a pretty lengthy proof. All right, so just go with that one. But the rest of them should be fairly easy. All right, so just as a couple examples as to how we're going to go through and compute these, let's go ahead and just compute a few of these by hand without using a calculator. And I'll show you that they're not too bad to be able to work with. So we have permutation 4-2, and this is our formula. So in letter A, we have n is equal to 4, because it's the first number, and r is going to be equal to 2. And we have our formula, that permutation 4, 2. So now I'm going to substitute for n, which is 4 factorial, and we're going to divide that by 4 minus 2 factorial. Right? Now, when you're computing these, I do see students sometimes trying to distribute the factorial. That's not legal. Remember, your order of operations says that you have to do what's in the parentheses first to be able to evaluate the expression. And so this is going to be equal to 4 factorial divided by 2 factorial. Now we can compute. All right? So we know that 4 factorial is going to be 4 times 3 times 2 times 1. And in the denominator, 2 factorial is 2 times 1. And this allows us to help us compute this very quickly because it's all being multiplied and we have a division going on. We can just cancel this out. We're left with 4 times 3, which is 12. And you might remember all the way back up when we did this problem. Remember we had 4, 2, and the very first problem that we did, so look back in your notes, list all the permutations of 2 in the set. I believe that there were 12 of those. It took us a lot longer to do it when we broke them out. So, but we didn't know what they looked like. We just did this part of the problem. All right, so it's one of those trade-offs. Now, let's do a combination. So now we have 4 combination 2. So for combination 2, we're going to use our formula, which is right here. We're going to substitute 4 for n and then 2 for r. So we're going to have 4 factorial divided by r factorial, which is 2 factorial, and then 4 minus 2 factorial. When we evaluate, this is going to be 4 factorial divided by 2 factorial times 2 factorial. Right? Notice that this is not equal to 4 factorial. You can't multiply those two and get an answer for that. All right, so what we're going to do instead is we're just going to expand. So let's just use our definition of factorial. So we know 4 factorial is 4 times 3 times 2 times 1. In the denominator, 2 factorial is 2 times 1, and then another 2 times 1, just like we did before. One set of the 2 times 1 can cancel out, and we could just multiply this out now. 4 times 3 is 12, 2 times 1 is 2, and by advanced multivariable calculus, 12 divided by 2 is 6. Now notice that if we go all the way back to the problem where we found all the combinations of 2 out of 4 elements, I believe that the answer for part B was 6. All right, so go back through your notes and check that. And again, this was a little bit quicker for us to compute. All right, but again, we don't know what they look like. And that's the trade-off, is do you want to know what the permutations and combinations look like, or do you just want to compute them? All right, so a final example of doing this by hand before I show you how to use the calculator, and this one's actually the easiest one, believe it or not, is we have this 10 over 2 factorial. And you're probably thinking about this and you're like, oh my gosh, we're going to have a huge number because of the factorials. All right, but it's actually not going to be too bad. All right, so let's just set it up through the formula. And as we do that, that's going to be, so in this case, n is 10, r is 2. And so we're going to use our formula right here. And so that's going to be permutation 10, 2 is going to be equal to 10 factorial divided by 10 minus 2 factorial. Now we know we're not going to distribute the factorial. That's just going to become 10 fact over 8 fact. And now we can just use our definition of factorial and expand those. Right? So we know that 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And just like we did in the other 2 examples, now we can just cross those out, and we're left with 10 times 9, which is 90. All right, so that's the suggestion I would make to you to be able to compute these permutations and combinations without using a calculator. All right, and showing all the steps, doing it by hand, etc. Now, let's see how we can use the calculator to be able to do these, because you can imagine, well, what if this was like 10.5 or 10.6? Well, this method doesn't work as nicely because then we have to do some long multiplication. That becomes painful. All right, so first of all, what we're going to do is we're going to go to our calculator. We're going to enter the first number. Then we're going to hit the math button. And under math, we go to PRB or PROB. Then we're going to select either NCR or NPR. We're going to press enter, and then we're going to press the second number. All right, so let's say we have 4.2. I'll bring this up on my screen. So I'm going to type in the first number, which is 4. I'm going to go math, which is usually right here. Okay, so just hit your math button. I'm going to go over to PRB. And again, on your calculator, it might be PROB. And I'm going to go down to combination, NCR, because I think it asks for combination too. Okay. And then I'm going to type in the second number, and then I'm going to hit enter. All right, and it gives us 6, which we already knew because we just did it 2 other times. So if I go back, for combination 2 by using the calculator is going to be 6. Okay. Now, what about 15.7? Well, that would be pretty difficult for us to do by hand. All right, so what I'm going to do is I'm going to start by typing in 15, and this is a permutation, by the way. It's 15 permutation 7. I'm going to select math. I'm going to go over to prob, and I'm going to select NPR because it's a permutation. And then I'm going to select 7 and hit enter, and I get 32,432,400. All right, so that's a lot of them. For 1 point of extra credit, if you want to write all of those out, so just pick 15 random elements, select 7, and write out all the permutations. You can get 1 whole point of extra credit. There are 32 million of those, so I wouldn't do that. I'm totally joking. Regardless, we're going to go back, and now we know the answer is going to be our 32,432,000. So for part B, 32,432,000. I think it was 400. You go back just to verify. 32432. Yep. All right. Now, hopefully for letter C, the number just doesn't work out as big. So let's give it a try. This time we're doing combination. So we're going to type in the exact same thing. We're going to type 15 math, except this time instead of NPR, we're going to select NCR. So we just select this one because it's a combination. We hit enter, we hit 7, we hit enter again, and 6435. Again, we certainly wouldn't want to write 6,435 different orderings out, but a little bit better. All right, so go here, 6435. All right. So hopefully now you're able to evaluate a combination by hand, and you're also able to evaluate a combination by using the calculator, and the same for a permutation. Able to do it by hand, to be able to list them out, and then to be able to use the calculator to be able to work with them. So now that we know all the different techniques for evaluating and trying to summarize these, now we can look at some example problems where we apply these. One final note, unless I specifically say to do it by hand to compute these, you can use the calculator unless I specifically say to evaluate by hand. Okay, so use the calculator unless otherwise told to evaluate by hand. Okay, so just because the numbers would get really unwieldy for us to be able to work with. Okay, so we'll see how to use the calculator in the next video to be able to work with some of these applied problems.